In section 6.3, we look at mole mass conversions, that is, converting between the number of moles of something and the number of grams, or the number of grams of something and the number of moles of that thing. So in the previous section, we saw how we can use molar mass as a conversion factor between moles and mass. Depending on what direction we want to go, whether we want to go from moles of something into mass, in grams, or whether we want to go from grams of something into moles, will determine how we're going to use the molar mass as a conversion factor. So pretty much what we're going to do is follow the procedure that we always do when we're doing a conversion. We're going to write what we're given. Could be our moles of A or grams of A. We're going to look at our units there and decide upon the proper conversion factor to achieve the conversion that we want. We're then going to cancel the units where possible, and finally we'll put all of our numbers into the calculator to get the new number with the correct units. So a good example of this is calculating how many moles are present in 100 grams of aluminum. And I know that the conversion factor between grams and moles is the molar mass. So the first thing I'm going to do is identify the molar mass. So there are 26.98 grams of aluminum in every 1 mole of aluminum. So now I'm going to write the starting units, and then I'm going to write the appropriate conversion factor. I must have grams of aluminum on the bottom and moles of aluminum on the top, and the 1 goes with the moles and the 26.98 goes with the grams. I cancel the units where I can, and that tells me that when I do this math, I'm going to get moles of aluminum, which is exactly what I wanted. At this point, I pick up my calculator and I do the math. So I'm going to do 100 times 1 divided by 26.98. And so that tells me that there are 3.706 moles of aluminum in every 100 grams of aluminum. And that's it. That's how we do these kinds of problems. Here is one where we're going to take moles and turn it into grams. So it reads, a biochemist needs 0.00655 moles of bilirubin for an experiment. Bilirubin is a compound that's associated with liver function. And it says, how many grams of bilirubin will that be? So the first thing that we're going to need is the molar mass of bilirubin. So I need to find carbon, hydrogen, nitrogen, and oxygen in the periodic table. And to get the molar mass, I'm going to have to add up the masses of everything that I've got. So I've got 33 carbons, 36 hydrogens, 4 nitrogens, and 6 oxygens. So when I add all of that together, 33 times 12.01 plus 36 times 1.008 plus 4 times 14.01 plus 6 times 16, what I learn is that there are 584.658 grams of bilirubin for every 1 mole. So this is going to become my conversion factor. So as always, I write what I am given, including the units, and then I'm going to multiply by the units that gets rid of moles and turns it into grams. So now I put my numbers into the correct spot, and then I check my units. The only unit remaining is grams, so I know I'm good. So 0.00655 times 584.658. And so 3.83 grams of bilirubin needs to be weighed out. And I gave my answer to 3 significant figures because my starting number had 3 significant figures. Okay. This one is kind of going the other way. It says a chemist needs 457.8 grams of KMnO4 to make a solution. How many moles is that? So I recognize that I'm converting grams to moles, and the conversion factor needed to do that is, of course, the molar mass. So I need to add together the masses of the atoms that are in my formula. So I have 1 potassium, 1 manganese, and 4 oxygens. So adding all of that up, tells me that there are 158.04 grams of potassium permanganate, KMnO4, in every 1 mole. And I should point out, potassium permanganate is sometimes referred to as Condes crystals and is often used for cleaning wounds. Okay, so now let's do our conversion. 457.8 grams. So I'm going to have to multiply by the conversion factor that has grams on the bottom line and moles on the top line, which is what we're trying to turn it into. And I know that in every 1 mole, there is 158.04 grams of KMnO4. So my grams will cancel out, leaving only moles. So I'm good to put that into the calculator. So 457.8 times 1 over 158.04. And I ended up with 4 significant figures, because this number here has 4 significant figures, 2.897 moles of KMnO4. So that's how we perform moles to mass conversions. Mole to mass conversions are relying upon knowing the molar mass of your compound or atom.